Greetings, the Astro 30 here yet again with a brand new video for you, and I've got another amplifier sitting on the desk to look at. This is turning into Astro's amplifier channel. Now, this is a Dick Smith Electronics, or DSE, model A2760 stereo integrated amplifier, and the fault with this is light flashing. Okay, so let's put this on the dim bulb tester and actually verify the problem. Alright, dim bulb is connected. Now I will preface this video by saying that this may not be a repair video because I have no idea if I can actually fix this, but turn it on and turn the dim bulb on. A little bit of inrush. And indeed, the LED indicator at the front is indeed flashing. What does this mean? Well, I'm going to assume, for all intents and purposes, this amplifier is now stuck in protect mode, which means it won't allow the connection to the speakers. So I'll turn the dim bulb off. And what we'll do is we'll pop the top off. I've already removed all the screws previously to make it easier. And we'll have a look inside. There we go. That was harder than necessary. So that's a good look at the inside. This is the power amplifier section plus input circuitry and protection circuit. Down towards the front is the preamp. Massive toroidal transformer. I'm going to probably assume that this is close to 500 VA, it may be less. It's low profile. And there's a couple of PCBs here at the front. One's a fuse board and one's the power switch board. And I did find a schematic for this, luckily, and there's no fuse protection for the power amps. You've got fuse protection for the preamps and for the protect circuitry, but not for the power amps. So yesterday I was messing around with this and I actually already disconnected the high current side secondaries from the power amps to isolate that to see if the protect circuit would engage. It did not. So I'm going to redo that test on camera so you can see that I'm not going insane. So return it on. So it's still stuck in protect. Light is still flashing away there. We also noticed there was very little to no inrush. That's because, well, it's disconnected. But the transformer is humming away. So I'll turn that off now. Alright, I can plug those back in. So where do we go from here? Well, it would be a good idea to first verify that all the DC supply voltages are present and correct. The protect circuit's around about 16 volt DC. The power amps are plus minus 45, and the preamps I reckon will be closer to the 20 volt plus minus. So let me set up a multimeter and we'll do some testing. Okay, multimeter is set up. I've got the negative probe connected to one of the negative posts of the speaker terminal, which is grounded to the case and grounded to the circuit. So in order to get voltages, I'm going to measure across these large diodes. I'll turn it on. And on the cathodes of this side I should have plus 45 volt. Maybe. There we go, 37. Yeah, okay. Might change the speed to high. And on the anode side, minus 37. Other channel, 37. Anodes we've got minus 36. So power supply rails for the power amps are there. As for the protector circuit, we've got 13 volt off of its full wave rectifier, I think that's what it is. No, it's a bridge rectifier. four-way bridge, and on the anodes, nothing because it's common ground. Alright, so we've got 13 volt on the protectors voltage rail. So we know the protector is getting power, or, well, obviously it would be, or else the LED wouldn't be flashing. As for the preamp, we've got minus 19 volt on that one. Nothing there. Nothing there. And 19 volt on that one. So the preamp's also getting power. So all the voltage rails are present and correct. Right, so where do we go from here? Well, I can easily, as it's powered up, see if either of these two output channels has any DC on them, which there shouldn't be because they were disconnected, so the protector circuit would not be detecting DC from the power amps. But that can be easily achieved measurement wise by going across the degeneration resistors in the emitters on each channel and just seeing what sort of DC offsets on each channel. So I'll start with the right hand channel. Got bugger all. And as for the other channel, about the same, bugger all. So there's a slight DC offset there, but not much. So I'm going to go on a limb here and assume that we've actually got a working amplifier. And it's just the protect circuit that's faulty. I can verify that by connecting an input signal, well, an input lead to the auxiliary input, turn the volume up and just touching the end of the lead and seeing if the DC offset on the output jumps around. Alright, got my input lead set up, so I'm just going to probe this channel, and it is jumping around. Give it more volume. Yeah, that's a working amplifier channel. Very easy. I'm just touching the end of the lead here. If I check the next one, it's a bit harder because it's the ring I'll have to touch, but that's also dancing around. So yes, we are getting output. Those heat sinks are actually warming up a bit. That's doing nothing. Okay, so we know that the amplifier itself, for as far as we know, is actually functioning, so it's passing a signal. So now we need to figure out why is the protect circuit not connecting the relays. And the two relays just live down here, by the way. So my thought would be we're missing relay drive. So the best thing to do would be to look at the schematic section for the protector circuit, just so you know where I'm going and I know where I'm going. So this is the protector section of the schematic. This is actually a KD-261. So this is a Dick Smith Electronics rebadged Chinese amplifier, probably Japanese amplifier, which was assembled in China. Actually it says made in China, so well, whatever. Anyway, here's our relays up here. So we should have, after this shunt regulator here, 12 volts. Now I'm going to assume, because the LED is flashing, that we do have some power there. So what I'd have to do is at V226 or at the cathode end of one of these flyback diodes and ground is measure to see if we've got 12 volts there. Next thing I would do is I want to see if there's base drive at the base of this transistor, because this is a Darlington configured driver stage for the relays, and this here resistor and this capacitor is our RC delay network. So if there's no base drive here or here, then these relays I'm not going to turn on. So that's going to be the next thing I'm going to do, is measure for any voltages in that area of the circuit. Alright, so we're in protect. Now I'll just measure across one of these cathodes We indeed do have 11 volt there, so I know that there is positive voltage going around the protect circuit. So the next thing I need to know is I need to know if there's base voltage drive for the driver. So this one is going to be V221, which is a 2SC945, and the base is on the right. We've got 6.8 volt there. Okay, so it is got voltage there enabling, which should enable it to turn on. As for the actual output transistor, which is a 2N5551, we've got 0.6 of a volt there. So those relays should turn on. But why are they not? Now the next thing I would do, I suppose, is this has a removable bottom cover for this particular PCB. I just want to get a good look at the underside of the PCB. I have gone ahead of time before shooting the video and checked the driver transistors to make sure they were conducting correctly with a diode test. Yes, they are. The Xeno diode that goes between the emitter and the base of the two transistors is conducting fine, and there are no open resistors that are obvious in the circuit. So I want to have a look at what the underside joints of the board look like. This is what I hate: screws that will not come undone. That's after already ruining a couple of heads, but they shouldn't be that bleeding tight. Thank the Lord for vice grips. I'll see what I can do about the screws later. Right now, all I'm interested in is getting this bottom cover off. Jesus. Head's a little marred on that. Might be able to fix it. Anyway, that aside, remove these final 4 screws that were giving me trouble because they're just way too tight. That seems an odd place for a screw. And we're in light fling. Oh, that joint there looks like absolute crap. I'm not 100% sure what's the deal here. Certainly doesn't look right. I'm not even sure what that is. That looks like one of the drivers for the power amp stage. But generally, just looking around the circuit board, I cannot see any bad joints. Okay, well, interestingly, the relay's engaged, but now the LED is still flashing again. That's odd. What I want to do now is I'll hook my multimeter up back to the output of each channel and see if there's a small DC offset there. Why the LED is flashing, I don't know. There may still be a problem. But I did hear both relays click in, and all I did was solder a joint round here. Alright, multimeter's set up. Turn it on. Come on, there we go. Measure one channel. Well, we do seem to have something on there. Other channel. Yeah, there seems to be offset there. This one keeps moving around for whatever reason. Okay. Oh, the LED stopped flashing now. That's interesting. It's permanently on. So, I wonder why this was triggering the protect circuitry when there was a slightly bad joint on this lead here, which I'm going to assume is a base connection on that transistor. I do not know, but it is completely odd. What I'm going to do now is I'm going to go through the underside of the board thoroughly, and I'm going to make sure that the thing does indeed work into a load, etc. And if I've repaired it just because of one bad joint, I'm going to be happy. Well, the LED is staying on permanent. It did start flashing a few times and now it's permanent, so there is probably still a dry joint under there somewhere. So I'm going to have to check that out. I think I've found a possible culprit. That joint there does have a hole, a cavity in the joint. So yeah, that might need to be resoldered. Well, not might be, will have to be. What I'm going to do now is I'm going to set up my oscilloscope and an oscillator, and we'll inject a signal into it and see if we get an output. Alright, everything's connected. Hopefully nothing goes off with a bang. It shouldn't. Pair it up and we'll see what happens. Ah, we have an output. So it went to protect because the current's too low because of the dim bulb. But that is indicative that we are getting an output. Okay. I will check the operation of the balance control might be a good idea. That's full right, so it's 0. Full left. Where's the center? There's the center. The treble. Probably won't see much. Might be a little bit. Let's try the bass. Okay, that's not doing anything. Let's try the switch the other direction. Nothing. Nothing. So that's obviously on, so I'll lower the frequency. Bass. It is having a small effect on it. Not sure what frequency we're generating. That's treble. Yeah, the bass frequency is being attenuated. Now try the treble. It doesn't seem to be having much effect. Ah, there we go. Yeah, no, the treble control's working. Okay, so I want to check the right hand channel now. So all I've got to do is just move my lead around. And we do have an output. It's going in and out of protect for whatever reason. Turn that down. Okay, so bass control. It's doing something. Treble control is doing something. Okay, so what I should probably do, I should take this off the dim bulb and see if the amplifier protect circuit behaves itself. It doesn't trip and, you know, whatever. That's only because it's going through a dim bulb. As I say, it shouldn't be an issue, which it's not. We have an output, so I'll crank the volume up. Whoa. Okay, I might have to reduce that. There's clipping. Ooh, 70 volts peak to peak. That is significant. Okay, so 70 volts peak to peak. Well, that's 35 divided by 2. 35 multiplied by itself equals that divided by our load. 153 watts peak. And if we take that same 35 and multiply it by 0.001 707 to get RMS, multiply that value by itself, then divide that by our load. Oh, now 76 watts RMS. That's significant. Okay, so I'll swap the output back to the other channel and see its power reading, which I'm not getting any because the lead clip is not connected properly. There we go. There's clipping, yeah, 70 volt peak to peak. They're both even. Yay. I want to see if there's a voltage difference between the channels. So currently I've got 30 volt peak to peak roughly coming out of the left channel. Seems to be more on the right for whatever reason. Just screw those in. Well, no, not really. Yeah, there is a difference. I don't know why one's got more output than the other. That doesn't make sense to me. We seem to have an imbalance of power output. Although that could be my leads. Hang on, let me just check this properly. So I've got it connected to the left on the actual connection itself. So we've got 16 volts coming out there. Switch the channels and I'll switch to the other side. It definitely is almost double coming out of that channel for some reason. Alright, well at this stage I'm not sure what the issue with that is, but for now I'm just going to leave it running on the dummy load for 5 minutes, go away, have a smoke, come back. Then I'm going to put it on an actual speaker and then compare the channels and see if one is indeed down with some proper audio source going through. As to the reason why there is a difference in level, I cannot really tell you at this point. There we go. Balance. It's treble. That's the bass. Bass is doing something. I can hear the treble doing something. Switch channels. It is definitely lower on the right. Okay. So we've still got a fault condition here somewhere. Oh. Ah. Yeah, okay. Oh, something's wrong with the preamp. Actually, no, it wasn't the preamp. It was the power amp. It's because of where the negative lead was connected. It was connected on the other side. Don't ever connect the negative ground for one speaker on the opposite side. It won't like it. And the magic smoke started disappearing around here, so it wasn't very happy. So let's see if we can get a signal on the other channel. Sounds better. Yep. Okay, so I'll have to swap my negative connection as well. To do that, I'll use another fly lead. And that one there, that one there. Maybe screw it in a bit. Swap my input. Okay, that's the left. Hopefully they're both joined now. Sounds pretty even to me. Indeed. Alright, let's check each of the inputs too. I'll check that. Yep. That. Yep. That. Yep. Need to check the right as well. Okay. Yep. 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 Okay, and record out. Yep. Let's try the left one. Indeed. Beautiful. Take that out of that mode. Yep. Okay. So, now would be a good idea to do a sound test in with some audio. Alright, got the computer hooked up. So, let's play a track. works. Right, now what I'm going to do is I'm going to finish this up, clean it up a bit inside, recheck all the joints underneath, make sure there's none that need resoldering, put the lid back on, and then we'll close this video out. Now, why did we have a hum through the speaker when the volume control was at 0 and smoke coming out of the power amp when we had the negative of the speaker connected to the other channel's negative instead of the one that the channel is connected to? Probably because we caused an earth loop, because these are two separate windings going into two separate filter banks. They are zeroly on the 0 volt joined together, but they're joined in a special way on the circuit board, not at this output, because they've got two cables going up back into here. So you can actually cause a problem that way, so that's the reason why. Other than that, I can't fault it. It's behaving itself now. It's no longer staying flashing even when it's not in protect. Right, so there it is, all there, put back together, turned on, and happy. So I hope you enjoyed that video. It was a very simple repair. It turns out just to be probably most likely a couple of dry joints here and there. I can't still see why that transistor, which is part of the right hand channel amplifier, I think it is, maybe the left, I'm not sure which one's which at this point in time, would be the cause of the issue. I don't know. But yeah, there was bad joints in there. So they've been corrected. For now, it's working. Both channels are even. Now that I've figured out that you don't connect the speakers up the way I was trying to do it. Anyway, I'm going to leave this video here. And if you enjoyed it, please remember to go down the bottom there and rate, comment and subscribe. And you can always follow me on Facebook and become a Patreon member for as little as $1 a month. Anyway, this is the Astro saying, see ya, have a great day. Another successful repair.